In this lesson, we're going to look at composite forces, which are the kind of forces that we see every day, and the main forces we'll study here in physics. But before we talk about that, I want to talk briefly about fundamental forces. And this is because all interactions in all of physics are one of four fundamental forces. So technically, anything we talk about is just really complicated interactions of four fundamental forces. And those are the gravitational force, the electromagnetic, the strong nuclear, and the weak nuclear forces. So force, 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 and force. So these are the only four forces that exist. I'll talk a little bit about each of them and kind of the rough history of physics here briefly. So gravitational force, we already mentioned, it's the pull between any objects with mass. So any object that has mass will pull on every other object with mass through the gravitational force. The electromagnetic force is the push or pull of objects that have either an electric charge or a magnetic dipole. So if you've worked with magnets before, or if you've learned like opposite charges repel, or opposite charges attract, like charges repel, that's all looking at the electromagnetic force. The strong nuclear force is the force that holds the nucleus together. So it's what holds protons stuck together, neutrons stuck together. All of those are stuck together through the strong nuclear force. The weak nuclear force is kind of the weirdest and like least commonly discussed typically, and that's the force that actually holds the parts of a neutron together. So if a neutron decays into a proton and an electron, that's because the weak nuclear force was involved with that. I should actually switch these two, and then we'll have them in order of strength. So gravity is the weakest. Strong nuclear force would be the strongest. And least range is at the bottom to most range at the top is kind of how we think about them. So things in the universe that are really spread out will typically only interact with the gravitational force because we're looking at really, really large masses that are mostly neutrally charged. Electromagnetic force is also technically infinite in its the way that it can affect things, but we don't see it acting over long distances. Strong and weak nuclear force are basically contact forces, meaning the stuff has to actually be touching for that force to interact, but it's a very, very strong force. Now, it's inconvenient to use those fundamental forces, and by inconvenient, I actually mean impossible. Because if we want to talk about like, why is my hand able to push against the wall? That's because all the electrons in my hand are interacting with all the electrons in the wall, and that's just billions upon billions upon billions of things that are interacting, and we just don't have computing power, or certainly not by hand, the ability to run all those calculations. So it's impossible for us to, like, we can understand how those fundamental forces combine together, but to actually model that, it's not possible or practical. So we instead summarize them into composite forces. So in other words, I summarize, instead of saying there's an electromagnetic force between my hand and the wall, I simplify it to just there's a push force between my hand and the wall, and I can measure how strong that is. So that's what we're talking about here, is taking something that's one of those, most of these common things that we see are actually just a bunch of electromagnetic forces all interacting, but that's complicated, so we summarize them into a composite force. So some examples here of composite forces. Let me make sure I got my notes ready. First, we have a normal force, and that's a push force that is perpendicular to two surfaces. So this is basically all of the kind of standard push forces that you think about. So like my two hands, they're touching, and if I'm pushing them against each other, the surfaces, there's a push perpendicular to that. So that's our push force between those two. So basically any push that you can imagine, me pushing a grocery cart, me standing on the ground and the ground pushing me up, that's all normal forces. And normal is just a fancy physics and math way of saying perpendicular. So that's why we call it a normal force. Next, we have the friction force. And this is a push force, kind of, that acts parallel to two surfaces and opposes motion. So it will always point in the opposite direction that an object is trying to move or succeeding to move. Next, you've got tension. And this is a pull force that acts along a cable or a rope or another object. Basically, if you're pulling on a rope, however strong you're pulling, that's the tension throughout the entire rope, and then results on the other side of being able to pull on the object or whatever it's attached to. Then you've got a spring force, and that's a push or pull force that opposes the stretching or compressing of a spring. So if you have a spring and you're trying to make it shorter or longer than its quote-unquote natural length is, the spring force will push or pull back to where it was. So if you're compressing it, you're squeezing it tight, it's going to push back against that. If you're stretching it, pulling it tight, it's going to pull back against it. There's other forces that you could name or describe. Thrust is sometimes used. I tend to avoid talking about thrust because it usually just causes confusion if we talk about it in this class. But there's all sorts of other things you can describe. But the point is, they're actually just for the most part, they're a combination of a bunch of electromagnetic forces. But there's also a couple that are some other things. But that's what a composite force is. It's a way for us to summarize some phenomenon and talk about the kind of interaction of multiple objects.